Back, everybody. Um, Today we're going to look at the into method. I don't know why I ended up on that one. Um, Into right here. This is Pipe Dreams Ramda Deep Dive Season 2. If you want to know what this is all about, go watch the first video in this playlist. Um, I just wanted to point out that I'm getting tired of writing out sample data. So I made a small little package called Some Data that gives us, we're importing everything as D. And so, for example, we could log d.list, and it's going to give us a list, or d.obj, and it will give us an object. And there's some others, and we can make random objects and stuff. So I might use that a bit instead of typing stuff out, and then also stop from littering up the file here with examples. So hopefully that won't be confusing, adding another library into the Ramda or along with the Ramda library. Um, so the into method, like I said, is kind of a doozy. I understand how it works, and I just said method, I meant function. Um, the only thing that throws me off is this word transducer. I'm not exactly sure what a transducer is, and we are going to get to this transduce function eventually. So I'm going to keep learning so I don't explain it incorrectly. Um, but that won't stop us from learning how to use this function. So let's start with the type signature. We take an A and then a function that takes a B and returns a B, and then a list of C's, and then we get an A back. So we start with an A, something of type A, and we get back something of type A. But let's look at the parameters here to figure out what all these letters are for. So the A is the accumulator, the initial accumulator value. So this is going to be a little similar to the reduce method on the array prototype or Rambus reduce function, where we have a list and we're trying to get a value, fold that down into a single value. Um, but the second function from B to B is a transducer function. It receives a transformer and returns a transformer. So again, I'm not exactly sure what the strict definition of a transformer or a transducer is, but I do know what a function is. And there is some special thing to this because they call it an XF instead of like FN. So obviously it's specialized enough where there's own naming convention for the argument. And then there's a list, which is our list of C's. And then it returns the final accumulated value, like a reduce function would. So, reduce function starts with initial value, or um, in the array prototype reduce, if you don't provide it the initial accumulator, it will use not the initial value for the accumulator. It will use the first item in the list. Uh, Ramda doesn't allow that. You have to specifically provide the initial value for the accumulator. So before we read the definition, um, well, we'll read the first part. Sorry, I'm stuttering. We'll read the first part here and then look at an example and then get back to this and try to understand it a little better. So it transforms the items of the list, or C's, with the transducer, or B to B, and it appends the transformed items to the accumulator, right? Which is going to be our A eventually. Maybe it's the A here. Um, Using an appropriate iterator function based on the accumulator type. So, appropriate iterator function throws me off because, I mean, I guess now that I'm reading it and saying it out loud, it makes more sense. It's a function that iterates like this B to B, like a map function or a filter function or reduce function. Um, it's iterating over all of the items in the list. Um, and then I'm going to keep going. The accumulator can be an array, string, object, or a transformer. Let's let's ignore the transformer part. Let's just say the accumulator can be an array, string, or object. The items that are iterated over, like the ones that go into our accumulator, iterated items will be appended to arrays and concatenated to strings. Objects will be merged directly, or two-item arrays will be merged as key value pairs. So the rest of this is one of these like specialized cases. Um, and I think it has to do with giving you more control over this, which is what the transducer or transduce function does. Um, but let's look at some code examples. So I'm going to use that d.list to give myself an array of numbers, 1, 2, 3, 4, 5. So just remember that's what that is. So if we do r.into, the first thing is going to be our accumulator. And remember, it says the accumulator can be an array, string, object, or a transformer. So let's start with an array. So again, this feels like when you're using reduce, the first argument is the reducer function. The second argument is the initial value of the array. And this is kind of like the initial, sorry, the initial value of the accumulator. And this is the initial value of the accumulator for the into function. Um, so the second function, and I'm going to just steal their transducer function here to start with at least. We'll put it up here. So the second argument is the transducer. And then the third argument is going to be our data. So I'm going to do a d.list, which will give us an array of 1, 2, 3, 4, 5. And if we look at that, we get 2 and 3, which is the correct answer. So what's going on is we're taking our list. We're using compose, so we're doing right to left composition. We take the first two elements of the array, which would be 1 and 2. We map over those and increment them by 1, add 1. So that would give us 2 and 3. And then what we do is we append those to our list, and we get 2 and 3. So if we just applied our transducer directly to our list, we're going to get the same thing, right? So it's like, why even use the into? But if we go and change our accumulator to a string, like an empty string to start with, and we run that, we get the string 2, 3. And so when it was the array, what we're doing is we're taking the first two, we're mapping over them, and then we're appending them to an array. If we looked at the append method or append function in Ramda, it takes a single value and an array, and it puts the single value at the end of the array, like inside the array. Concat would take two arrays and merge them together. Like take the first array and then stick the values of the second array and put them inside the first array, or a copy of it technically, because we're not mutating. Um, but we could switch this back to a string, and now it's going to append the results because you can't concat a string, I don't think. but it does. Oh, I'm sorry, you are concatenating a string. You can't append a string. An append needs a list. Um, but anyway, that's how it works. So you've got, whatever accumulator you use, the values returned by the transducer function are going to go into your accumulator using the appropriate iterator function based on the accumulator type. So the appropriate one for a an array or a list would be append, and the appropriate iterator function for a string would be concat. And that's what they say here. Iterated items will be appended to arrays and concatenated to strings, and then objects do their thing. So let's try an object. This may not make sense based on the data that we have, but it shouldn't crash. Yeah, that doesn't work. Um, but okay, I have one called. I have some data called d.entries. By the way, this is all typed in stuff, so you do get code completion. So there's entries, list, matrix, all these different guys here. But if we did entries, it looks like this. It's an array of pairs, A and 1, B and 2, C and 3. So if we pass that into our into function, I clear this. Uh, oh, it's because our transducer function doesn't make sense here. Let's copy this and slightly modify it. And instead of adding, because we can't add to a pair. Our pair is like a string key and number value, and we can't add one to an object. So we'll just do R to upper. That may not work either. Yeah, no, that won't work. And it won't work because you can't uppercase an object either. Yeah, A1 does not have a method named to upper. So we'll just really simplify this and we'll just take two. Take the first two letter objects rather. No, I'm saying objects. Our first two pairs. Since I'm messing up, let's look at that data again. Yeah, a pair, a list of pairs. So we're going to take the first pair and the second pair, and then since we're using an object, we're going to merge directly. And actually, we're using two item arrays. So two item arrays will be merged as key value pairs. I think it might be that one. Let's try it. Let's comment this out. Right. So that just switched some entries or pairs into an object, but it's a flat object. Um, and I think that's what that means. Objects will be merged directly. So it's really all about the type of the accumulator that you use based on what's happening. But regardless of what I use here, I can use an object with that transducer, and I get what you see in the console now. I could do a string, and then I get it like that, because we're concatenating now. Here we're merging objects. This is a merge right, I believe. And then this is the concat. And then if we use an array, we're going to get back what we would have gotten back anyway, because take two is taking an array and returning an array. Yeah. So we basically just get the first two elements of our array back. We could do this with a string, since strings are, this is a list function, but strings are banana. Strings are like arrays in Ramda. And here now we can go back and put in r.map, r.upper to upper. And let's see what we get. Kind of think about it, maybe pause if you need to, and think about what we're going to get in our final output while I take a sip of coffee. Okay, so let's run this. And we get an array at B and A. We did an object. Not sure how that's going to work given the string data, but let's just see. Yeah, I see what happened. B is at the 0 index, and but why do we get A? I don't even know. I'm not going to worry about solving that mystery. But if we did I mean, because you wouldn't try to put this in an object anyway. But if we take our banana and we use a string as our accumulator, then we get the uppercase BA as a string. So all we have to do is really solve, why is this function up here, this partially applied function, considered a transducer versus just being a partially applied function? I mean, it is a partially applied function. It's both. It's the partially applied function at any point, but in this particular case, it's a transducer. So hopefully by the time we get to the T's, which will be quite some time from now, I'll have my head wrapped around it. I do know that a transducer is sort of similar to a reducer function, but a transducer actually takes a reducer and returns a reducer. So that's what's confusing to me. Not exactly sure how that works here. Um, but let's look at their example here. So let's go back to their transducer function example. And let's go back to providing a list. So this is an array of 1, 2, 3, 4, 5. And we're going to go back to an array. And so what they've done is they've created this function called toArray and partially applied it with the first argument, which is an array. And then let's make one called toString. And then we're going to need to do something else with the function because this isn't going to work with a string. Why don't we use intersperse? Yeah, that should work with both. Intersperse. Maybe we can use a taco. And then let's try calling our functions to array using our transducer and our d.list, an array of 1 through 5. Clear all that and check out our error. Invalid array length. Hmm. I thought that would work. We don't need a map over it. What does the intersperse take? Takes an array. It takes an item and then an array. There's our item. We're passing in an array. Same error. Okay. Rather trying to, instead of trying to figure that out, we'll just use this very simple one transformation here. So yeah. Um, so this isn't really doing too much. I need to think of a better example. Um, what if we did our entries? Yeah. Okay. So this is just taking the first two entries and putting them into an array because we're using the to array. We're telling it to use the array as an accumulator. So it takes the first item, puts it in the accumulator, and then it appends on the second go round, it appends the second item into the array. But if we change this to string, then we get something that looks like this: a comma 1, b comma 2, all concatenated together as one string. It's almost like joining it at the same time. So anyway, that's into, I don't want to look at the code for it, and I'm not even going to try to figure out what all this means. Yeah. So again, I have a hard time trying to figure out why you would use this, but it's here, and the people that work on Ramda, they spend a lot of time discussing this stuff. So people that are smarter than me have decided to put it in. It wasn't there originally. It was added in 0.12, um, but that's still some time ago. It's not as old as some, but it's newer than many. Um, we'll go ahead and take a look at invert too, just uh, an invert object, because these aren't so tough. And it says here in invert, which is an object function, um, same as r dot invert object, however, blah, blah, blah. So that makes me think we should look at invert object first and then go back to this one. So let me clean this up a little bit. So if we look at the object signature, it's very clear what this does. It inverts an object, right? So we pass in an object, and it with the key value, the key is a string, the value can be anything, and it returns an object that just flips it, and it inverts it. Um, so the value becomes the key and gets turned into a string, coerced into a string, and then the value is the uh, what the key was when you passed it in. So I guess the resulting object has to be a string and a string. The object or array to invert, and it returns the new inverted object. Returns a new object with the keys of the given objects as values and the values of the given objects, which are coerced to strings, as keys. Note that the last key found is preferred when handling the same value. So yeah, given duplicates, the last one wins. Uh, so using my sum data package, I have something called an object. It looks like this. ID1 name test active true. So we're going to use that. I'll leave that in the console for a second. So if I want to say r.invert object, and it just takes the one argument, the object. So I'll pass in d.obj, this thing here, and let's run it. Yeah, and if we compare it side by side, so that was our original, and this is what comes out. So instead of ID1, we have one ID, and it is a string. Now, test doesn't look like a string, but we know that since it's an object key, it is a string for all intents and purposes. And then instead of active true, we have true active. So, yeah, you know, this is what you do when you need to use this. I wonder if it's as easy enough just to implement myself. It would take an object and it would return a new object with the obj key. Is that how you would do that? You know what I'm do is that if I just restructure it right here. Um, so we take the key and the value, and then we just return an object, which we're going to have to wrap in parentheses, put it on one line, and then we would just return the value and the key, and then call that one. And we get that thing. So, and that B looks like it's not even being used. We need to wrap this in parentheses or square braces to, I can't think of what the word is, basically to change that into a value. Um, so that gives us undefined, undefined. So yeah, it's not trivial. There's something to this. What happens if we wrap the key in square braces? No, that doesn't do it. I don't know what I'm doing wrong here. I mean, if we just output the key, what do we get? Undefined. And if we output the value, I don't know why that doesn't work at all. Is it because the key, I mean, there's three keys and three values in here, and I'm just destructuring it like it's one. Yeah, I don't know. And I don't really care right now because that's a bit off topic. I mean, the point is, it isn't trivial. I need to do r dot invert object. Yeah, it's not trivial, so that's why this exists. And it could be useful, if you're just trying to take data that's given to you or that you fetch and then try to change the structure for your needs. So that's invert object. And then let's go look at invert. And it says it's the same as r.invert object. However, this accounts for objects with duplicate values by putting the values into an array. So if we compare, we take the first thing is the same. It's an object, key value. And instead of returning another object with a key or with a value key, we're returning something with a value that's coerced to a string and then an array of the keys in case there's duplicate keys. In this case, I'm going to need to create my own data. I'll just call it obj and we'll say, um, let's do this. Let's cheat. Let me say log d dot users It's a function that takes a number of users, so we'll take 3. And then, yeah, that gives us this. Where did that come from? I'm not sure. But anyway, I'm just going to steal this, use this as my data. So we'll just call it users. So we'll pass it users this time, and it's just called invert. And let's see what we get. Interesting. Oh, because we need an object. Okay. So what if I just made this an object of objects? That wouldn't work. Let's just take theirs. Sorry. All right, let's see what we get here. Right. So we're flipping these. Alice is first, Jake is second, but we have another property with the values the same. So we're going to end up with 2 keys called Alice. So instead of just having the last one win, which is what the case would be if we had duplicate keys, instead we get back an object with Alice as the first key and then an array of values, first and third, and then Jake second. If I test that theory, if we duplicated the key second and said John, we get Alice first and third, John second, but it just ignored this line because this line is essentially overridden by this one. So yeah, invert and invert object. Now, if we do take a look at the code of this one. Sorry, I got sidetracked because I saw some more information, but this one does some stuff. Uses a while loop, and you know, uh, the point was I just wanted to show you that there's an implementation for invert object, but when we go to invert and look at the function implementation, oh, this isn't what I thought it was. I was thinking it was using like invert under the hood was using invert object or vice versa. Make sure I didn't click on the wrong one. No, but that's not the case for this one. So we're going to ignore that because I don't want to just try to figure out what that imperative code means, and it relies on other functions that are internal, so we have to go look that up. So we'll ignore it. I think we understand what invert does. I think we understand what invert object does. Um, as a side note, wouldn't it be cool if we could write, instead of using TypeScript, if we could write these type signatures and comments right above our functions and then have our editors type check based on this? Because I mean, sometimes these can get really gnarly looking, but most of the time, I feel like these are much more clear and concise than TypeScript types. But anyway, if somebody can make that happen, that'd be great. Yeah, I saw this alternately. If we used an array to pass in, and an array is an object. So I'll go back to my thing here. We'll invert. Is that invert object? Yeah, we'll go back to invert object and we'll pass it the DDAT list, the list of 1, 2, 3, 4, 5. invert object. Yeah, see what it does? It takes the key, which is the indexes for the array, 0, 1, 2, 3, 4, and it puts that last as the value. And then it takes the values and changes it to the key. So this is like similar to using object entries, or this actually would be the other way, wouldn't it? Would be from entries. I get those mixed up. Yeah, from entries because well, I don't know which one it is, but the point is it's treating an array like an object and treating the keys that are under the hood and kind of exposing them when we put it into an object. So maybe you want to do this sometime. I don't know. Um, but I think that's good for today. We're gonna go pick up on Invoker, and I really like this function. I wish I'd known about this a long time ago. It would have been helpful. And then the rest of these functions are these predicate functions that start with the word is. They're pretty easy. So we're gonna get through all these very quickly, maybe in their separate video, maybe in the same video where I pick up on this. Anyway, I hope you learned something. Thanks for spending your time with me. Tell a friend, and I'll see you in the next video.